When you think about the question of where are the aliens, which I get asked a lot, this is like the Fermi paradox. Where are the aliens? And I've not seen any evidence that there are aliens on Earth. A lot of people think there are aliens on Earth, and I'm like, great, I'd like to meet one. You know, for a while there, when I was getting my green card and everything, it said alien registration card. I'm like, okay. But this question of where are the aliens is, I think, a very profound one, because I'm aware of no evidence of aliens whatsoever, which means that I think we're probably alone. And if you look at the history of Earth, like how long has Earth been around? Assuming that physics is correct, the universe is about 13.8 billion years old. Earth is about 4.5 billion years old. When you think about how old is civilization, I think the right measuring point for civilization, in my view, or a good measuring point, would be the advent of writing. So the first writing is generally considered to be the ancient Sumerians. Where are they now? They died out. But about 5,500 years ago, it was archaic pre-cuneiform. In fact, I suggest it's like an interesting rabbit hole to read about the history of writing. So if you consider, say, like, okay, civilization, I think if you don't have writing, you kind of need writing for civilization. It's only been around for like a little over 5,000 years out of 4.5 billion years that Earth has been around and the 13.8 billion years of the universe. So all of human civilization is basically the blink of an eye. It's like just a fraction, it's nothing. And I think that probably means that consciousness is incredibly rare and perhaps fleeting. It may not last for very long, because otherwise I think we would have seen aliens, some kind of sign of aliens. I think the most likely explanation is that consciousness is so rare that and does that consciousness actually extend to another planet? Does that consciousness extend to another star system? I mean, ultimately, if we're able to become a spacefaring civilization, a multi-planet species, and ultimately a multi-stellar species, and go out there and explore all these star systems, I think we may find that there are many long-dead one-planet civilizations. And as you've heard me say before, we don't want to be one of those lame one-planet civilizations. I mean, we want to be a multi-planet civilization, ultimately be a multi-stellar civilization, be out there among the stars. Like, you know, make science fiction not fiction forever. Kind of make Star Trek real. So that's why I think that there's a high urgency to making life multiplanetary. Because this is the first time in Earth's 4.5 billion year history that it's been possible to extend life or consciousness beyond Earth. And we've got to do that while civilization is still strong. So that's the overarching goal of the company, is extend life sustainably to another planet. Mars is the only option, really. And to do ideally before World War III or some kind of bad thing. The key thing is that we need enough people and enough tonnage on Mars such that Mars can survive and continue consciousness even if something would happen to Earth. Now, I still think, well, obviously, I'm not talking about abandoning Earth or anything like that, and we want Earth to be as good as possible for as long as possible, but there are certain things that may be outside of our control. So we want to just get Mars to be a self-sustaining civilization as quickly as possible. And I think this can be done in around 20 years. And this giant Starship factory that we're building is obviously key to that. And the launch sites that we're building here and at the Cape and elsewhere in the future will be key to that. So let's just go through that.
This is the final go, no-go poll for Flight 3 of Starship. Goodbye 2.
Go.
Stage 1.
Go.
Stage 2.
Go.
Flight directors, go for launch. We have liftoff.
Vehicles pitching downrange. Next cue. Vehicle supersonic. Stage separation.
And congratulations, guys. You did that. That's insane. I mean, it looks like CGI. Hard to believe that that is unfiltered video. That's just the actual what the camera saw. No filters, no nothing. That's actually what the camera saw, which is insane. You know, you're doing incredible work that I think almost no one thought would actually happen. It's wild that this strange spot, we're basically on a sand spit by the Rio Grande, near the beach. And that is actually the gateway to Mars. It has to be like, if this was a movie, you'd be like, no way. Come on, too implausible, but it's real. And it's due to you guys. Congratulations. This is a side-by-side of the 3 flights. You can see our thruster weight improved significantly. So we've made tremendous progress from Flight 1 to Flight 2 to Flight 3. And we got Flight 4 coming up in about a month or so. And with Flight 4, we should, if we get, if fate smiles upon us, we'll get through the high heating regime and smash into the ocean at a controlled spot, and then to hopefully be able to also do this with the booster, land on essentially a virtual tower. If the landing on the virtual tower with the booster works, then we will actually try with Flight 5 to come back and land on the tower. Yeah. That's very much a success-oriented schedule, but it is in the realm of possibility. But I would say, like, the odds of us actually being able to catch the booster with the Mechazilla arms this year, I think, I don't want to tempt fate, knock on wood, but I think the odds of actually catching the booster with the tower, probably like 80, 90% this year, which is insane. Like, actually, when we first talked about it, it sounded so batshit crazy. We're going to have a giant, it's like literally bigger than Mechazilla from this movie, that you'd catch like the biggest flying object ever made with mechanical arms out of the air. But we're going to do it. Yeah. It may not work, necessarily the first time, but it will work. So really, Starship is really the key to making life multiplanetary and preserving the light of consciousness. That's what it's all about. And it may end up being the most important thing that we ever do. I think that the light of consciousness is like this tiny candle in a vast darkness. And that candle has only been lit for a very short time, and it could easily go out. So we obviously want to preserve the tiny light of consciousness on Earth, but extend it to Mars, and then ultimately to the rest of the solar system, and then start going to other star systems. And I mean, I won't be alive to see that, but unless I'm like frozen or something, I don't know. But I think at some point we will discover many civilizations that maybe lasted 1 million years or 2 million years or 10 million years. But a civilization that lasted 1 million years, which would be vastly longer than our civilization has lasted, only the third decimal point, so like 13.8 billion something years. If your civilization lasts 1 million years, it's only goes, that third digit past the decimal point goes up 1, and that's 1 million years. I mean, I'd say, like, we should think of, like, how do we make civilization last 1 million years? We often get caught up in, like, the day-to-day things, but we want to have at least 1 million-year civilization, if not 100 million-year civilization, or 1 billion-year civilization. Absolutely crucial to that goal is becoming a multi-planet species. People often ask, why Mars? Well, there's not a lot of options, frankly. Venus is a superheated, high-pressure acid bath. You don't want to go to Venus. And then the moon is close, but it doesn't have an atmosphere. The gravity is only 1/6 that of Earth, and it's missing a lot of key resources. Also, the insulating value of the moon relative to Mars is much less. So if there's something that takes out Earth, like let's say there's a World War III, global thermonuclear warfare, they'll probably throw a few nukes at the moon. Whereas it's way harder to shoot Mars with nuclear. And Mars would see it coming and probably have some time to stop the inbound missiles. So the value of Mars, the distance and time required to get to Mars actually has an insulating benefit for the continuation of consciousness, even if there's something terrible happens on Earth. And then once we go beyond Mars, there's some asteroids like Ceres, some of the moons of Jupiter. The Starship would ultimately be capable of reaching anywhere in the solar system. Then we'll need something, a new level of technology to go to other star systems. But if we can't at least get to Mars, then other star systems are hopeless. I mean, it's a fixer-upper of a planet, okay? It needs some work, but it's really the only option for becoming multiplanetary. And long term, we can warm up Mars, and we can densify the atmosphere, and there'd be a liquid ocean on about 40% of the surface. So we could make it an Earth-like planet long term. Let's see. We've learned a tremendous amount from when we started the company, and at first were unable to get even a small rocket to orbit, to now where we've done 327 successful launches, almost 300 landings. In fact, give it a few weeks and we'll have done 3 landings. 261 Many times I was told that reusability was impossible, and even if you did it, there would be no point because nobody would want to fly rockets that much. But now we routinely fly and land the booster, and we recover the fairing. So we've learned a tremendous amount from the Falcon program that is then feeding into the Starship program. And Falcon and Starlink are what obviously keep the company going. I'd just like to give a hand to the Falcon team for the incredible work that they're doing. And then Dragon, wow, 45 launches of Dragon. It's amazing. And we've flown 50 crew members to orbit, 46 to the space station, and everyone has come home safely, which is the most important thing. Incredible work by the Dragon team. So let's give them a hand. Couldn't ask for a better outcome. And Starlink, actually, if you look at the sort of the plot of all the satellites going around Earth, it does look kind of scary, actually. But there's 6,000 satellites in operation, over 6,000, and 10,000 lasers, almost 3 million customers. So Starlink is doing a lot of good for people on Earth who either don't have internet access or it's very expensive. And so it's doing a lot of good, on Earth. Because when I say we want to be a multi-planet species, we obviously want Earth to be as good as possible, and Mars to be great. So Starlink is doing a tremendous amount of that, and we're learning a lot by having this big fleet. Starlink will also be very important for high bandwidth communication to and on Mars. From a tiny rocket to Falcon 9, which is a much bigger rocket, many iterations of Falcon 9, and then Falcon Heavy, and then Starship. And Starship will get bigger, obviously. This year, if things go according to plan, SpaceX will do probably 90% of all Earth mass to orbit. And then China will do about 6%, and the rest of the world will do about 4%, which is pretty wild. And then once Starship is flying, we'll be doing over 99% of all Earth mass to orbit, which you kind of have to do in order to build a city on Mars. And I should say we'll also build a lunar base as well. It might as well, along the way. You can see that actually Falcon 1 was really, half a ton to orbit. Slight error on the slide there. Falcon 1 was about half a ton to orbit. Falcon 9, depending on in expendable mode, would do probably 25 tons to orbit. And Falcon Heavy, probably 70. Anyway, these are just obviously rapidly increasing numbers. And Starship in its final configuration or its final form will probably do well over 200 tons to orbit with full reusability and be able to fly multiple times a day. So I'm pretty confident we will achieve that this year. Like I said, probably 80–90% this year. And then there's recovering and reusing the ship. The ship will take longer. So the ship, I think we will want to have at least 2 consecutive successes of a given design that land at a specific point in the ocean or smash into a specific point of the ocean before we try to bring it back to the launch site, because we do not want to rain debris over Mexico or the US. My guess is probably next year is when we will be able to reuse Starship, but I think it's highly likely that this year we will bring Starship or the ship side of it, to a controlled point in the ocean and have it basically land on a virtual tower somewhere in the Pacific or the Indian Ocean. And we've already proven that we can do the final phase of landing, coming from sort of a belly-first position to rotating the ship and landing vertically. We proved that right here. We just need to be confident that we can get through the high heating portion of reentry reliably, and then we will bring the ship back and it will land on the tower as well. And we're going to build more Mechazillas. So there's going to be 2 launch towers here, and then 2 launch towers at the Cape as well. So we'll have 4 launch towers for Starship, probably by sometime next year. Aiming to have the first Cape launch tower and launch system operational around the middle of next year. And that'll be important for launch that are sort of fly over land. So I think what we should probably expect is that we do the development launches here, test anything new here, build the rockets, And then probably most of the operational launches would be from the Cape. So this year we're planning to build another roughly 6 boosters and ships, and that production rate will increase a lot next year. That's why we're building the giant factory. Ultimately, we'll need to build a lot more ships than boosters, especially for Mars, because you'll actually want to use the ship, take apart the ship and use it for raw materials on Mars, because the ship materials will be so valuable. Most of the ships you wouldn't want to bring back. You'd want to just use them for raw materials. Eventually, we will want to bring ships back, and I think we want to give people the option of coming back because they're more likely to want to go if there's... But I think most of the people that go to Mars will probably never come back to Earth, and we'll need to ramp production to pretty high numbers. Like, I think ultimately probably a ship every... multiple ships per day, basically. And then next year, we're aiming to demonstrate ship-to-ship propellant transfer. It's hard to make this not look a little bit naughty, because it's 2 ships connecting and doing a fluid transfer, just what it is. But this is actually a very important step on going to Mars, because you need to get the ship to orbit and then do orbital refilling, kind of like aerial refueling. And that's really, you'll need about 5 or 6 refilling missions for every 1 mission that goes to Mars. So roughly 5 to 1. And this will also be very important for the Artemis program for the NASA to get back to the moon. So we'll want to have a ship that is, well, it's going to be a specialized ship for the moon, like this. So the moon, obviously, there's no mechazilla, so we need landing legs. And you don't need a heat shield, and you don't need flaps, because there's no atmosphere. So the moon ship would be specialized. And now, ultimately, I think we want to build a Moonbase Alpha and have a permanently occupied base on the moon. Like, that would be super exciting. And so you'd have a bunch of ships that are specialized for going to and from the moon, but they never land back on Earth. They just would dock with propellant tankers to get orbital refilling. So in terms of performance, we've made dramatic progress on every level for Starship. It's remarkable that you can see the Raptor engines and how it has evolved from, optimistically 185 tons. And I think ultimately the booster engines, will aim to get the booster engines over 330 tons of thrust, which would mean 10,000 tons of total thrust at liftoff. And then the Raptor 3 also will not need a heat shield. So Raptor 3 looks very simple, and it is actually simplified in a lot of ways, but a lot of the complexity is hidden because we have integral cooling channels in many parts of the engine that don't exist in Raptor 2. So in order to not have a heat shield, it has to be very resilient. But that is actually what Raptor 3 would look like. Raptor 3 looks like it's missing a bunch of parts, but actually those parts have either been deleted or they've been integrated into the system, and like I said, with integral cooling channels. And where you need secondary plumbing, the secondary plumbing has also been integrated into the pump and into the chamber jacket, and so it's much simpler. It's actually extremely difficult to build Raptor 3, but it will be easy to integrate, and will have higher performance and lower total mass, and be more reliable. Well, that can go on for a while. I find it interesting to look at if you look at the flame tail on Starship and how long it is. It's a very long flame tail, which is due to the fact that the chamber pressure, it's just outputting a lot more gas at a higher velocity. But I think the flame tail is like maybe 1,000 feet long. It's like more than twice the length of the rocket. And that will actually as we increase the thrust, that will get longer. Yeah, and inevitably the rocket grows in height. Starship 2, we're aiming for, currently Flight 3 would be around 40 or 50 tons to orbit. So the current design, Starship 2 will be over 100 tons, and then Starship 3 will be over 200 tons. It's gone from around 7,000 tons thrust to over 8,000, but I think we'll end up ultimately with more than 10,000 tons of thrust, probably 7,000 or 8,000 tons of liftoff mass, and at least 10 meters taller. We'll see. Tends to grow. Yeah, exactly. It probably grows a bit more than that, even really. So if you look at Falcon 9, we're not going to do the length to diameter of Falcon 9. That would be crazy, but Falcon 9 is a very long rocket. And so I suspect it'll probably get a bit longer than this. But at 200 tons per flight, fully reusable, that is pretty incredible. And this will be on the order of 500 feet tall. And then there's thousands of design improvements here. I mean, I think maybe one of the most profound things is Starship 3 will cost less per flight than Falcon 1. So that's the difference between if you've got a fully reusable rocket or an expendable rocket. The fully reusable rocket with low-cost propellant and autogenous pressurization actually costs less than a tiny expendable rocket. And it'll do, like I said, Falcon 1 is about half a ton to orbit. The Starship 3 will be 400 times more payload for less than the cost of a Falcon 1. Ultimately, I think we might be able to get the cost per flight to Earth orbit down around $2 million or $3 million. These are sort of unthinkable numbers from the, nobody ever thought that this was possible, but we're not breaking any physics to achieve this. So this is within the bound, without breaking physics, we can do this. So the Mars missions are 2 years apart, or 26 months. And if you look closely at the Starlink router, you see the home and transfer from Earth orbit to Mars orbit. And that's basically to say to people, the Starlink system that you're buying is helping get humanity to Mars. I think it's pretty cool. So roughly every 2 years, thousands of ships would depart from Earth to Mars. It would look like Battlestar Galactica, but in a good way. Hopefully without being chased by the Cylons. But it would be an incredible thing to see these thousands of ships departing every 26 months for Mars. What this diagram is basically saying is that for getting to Mars, we would essentially create a kind of a propellant depot ship. The propellant depot would look more like a hot dog than like a sphere. It's really just a long ship with a lot of insulation. And we'd fill that ship up, and then shortly before, or as they're going to Mars, the ships would take off with, I don't know, a couple hundred tons of payload from Earth, reach orbit with almost no propellant, and then get refilled by the tanker, and then go to Mars and go all the way to Mars with over 200 tons of useful payload. Then on Mars, in the beginning, we would simply reuse the ship materials, so most of the ships wouldn't come back, but then over time, you'd want to bring the ships back so you could reuse them. And for that, we would need to create methane, CH4, and oxygen, O2 on Mars, which you can do with H2O and CO2. So the atmosphere is CO2, and there's plenty of water ice, H2O. And so it's tailor-made for, well, actually, the reason we have a methane oxygen system is because you can make methane and oxygen on Mars fairly easily. Like just not a total walk in the park, but the ingredients are readily available to create methane and oxygen on Mars. So you build a propellant depot and bring the ships back and build out, as quickly as possible, a self-sustaining civilization on Mars. And we want to get the cost of going to Mars such that almost anyone could afford it. Like if somebody were to just work hard on Earth, save up, and that they'd be able to go to Mars. So it's like anyone, ideally, almost anyone could go to Mars. And I think you'll see a lot of governments also sponsor people, and ultimately we want to get, so there's kind of an optimal landing zone on Mars where you have resources, so you've got access to water or frozen water, that you're not too close to the poles so you can use solar power. It would be nice to use nuclear. I don't know if we'll get the approval, but nuclear would be very handy on Mars because you can use the heat and you can generate electricity. And then you kind of want to be about 2 kilometers below sea level. So if Mars did have an ocean, you'd actually be quite deep in the ocean, at least at first. And yeah, let's see, that's Mars. Kind of want to land about halfway between the pole and the equator in a kind of a deep area of Mars. The deeper it is, the more you can use the atmosphere to brake, and the atmospheric density is higher. These are all the things that would have to be developed. Sometimes people ask me, are we developing these things? I'm like, not yet, because this is the cart, and we need the horse first. So the rocket is the horse, and then this is the cart. But ultimately, we'll need all these things, lots of power generation, mining in general, ice mining, propellant production, long-duration life support, a lot of construction, and then global communication. So I think this would open up a lot of opportunities for entrepreneurs that want to create things on Mars, whether that is a propellant. Well, I think we'll have to do the propellant depot, but whether it's like iron ore refining or a pizza joint or a bar, there'll be an opportunity to do all the things that we like on Earth on Mars. Like a Mars bar would be great. So I think probably a rough order of magnitude guess for what you need, how many people do you need for a self-sustaining city is about 1 million and several million tons of cargo. Yeah, which we can do, and we can do this in 20 years. But like I said, in order for it to be self-sustaining, you actually need the entire base of industry. You can't be missing any element. So that's really what's going to take a while. Is, do you have everything you need to survive on Mars? At that point, you can start a lot of the future of consciousness is assured. If you do 10 launches a day at 200 tons per launch, 1.5 million tons to LEO per opportunity, you net that out to 250,000 tons to Mars per opportunity. So that means you can get to 1 million tons in about 8 years, since the opportunities are 2 years apart. So I think this is pretty doable. And I'm like, we're actually going to do this. Are we? Well, we are actually going to do it, which is insane to think. Millions of tons to Mars. Wild. And we're going to build a lot of vehicles. Several thousand vehicles per year is what we'll need, which really quite doable, actually. It sounds like a lot, but it's very doable. Yeah, if you compare it to sort of car production, it's a small number. Of course, this is much bigger than a car, but even if you look at the total tonnage, it's still very doable to build several thousand vehicles a year. That's what we need to do, and we're going to do it. And then long term, we'll probably have some offshore launch sites. You can just imagine all of these starships waiting in orbit for the planets to align, and then this gigantic Starfleet taking off from Mars. All right, so we're actually going to do this. And when you think about where this started out, this was literally just like a sandbar where we're standing right now. And now look at what we've done here. And that we've gotten 3 flights off of Starship, and we've got a 4th one coming up. And we're building a gigantic factory that will be able to output a massive number of ships. So it's surreal, but it's real. So we're actually going to do this. We're going to take humanity to Mars. And I'm confident you can do it.